In this lesson, we are going to learn about isotopes, isotones and isobars and learn some examples of these things. What is an isotope? Isotope have same atomic number. They are the same element, but they have got different mass numbers. They got same Z, but different number of neutrons, different mass number, right? Z is number of protons, N is number of neutrons, and A is called mass number. This is Z plus N. So isotopes have got same Z, but different N and different A. One example of isotope is the various isotopes of hydrogen, right? Hydrogen typically has got only one proton, so it is having a mass number of 1. Then you have got deuterium, which has got a mass number of 2, and tritium, which has got a mass number of 3. All are hydrogen, right? Same element, but the mass number is different, neutron number is different. They are isotopes. Next example, carbon 12 and carbon 14. Both these have got 6 protons. They are the same element carbon, but in the first case the number of neutrons is 6. In the second case the number of neutrons is 8. This is radioactive. Carbon 12 is stable. Carbon 14 decays by beta decay and it converts to nitrogen 14. Right? That is very important, is for carbon dating, to find out how old is a particular rock, fossil, some tree. Okay, you can find out using this concept. Then you have got the isotopes of uranium, uranium-235, that is used in nuclear reactors, and uranium-238, which is more abundant on the Earth's surface. On the Earth's surface, you got 99.3% of uranium-238 and only 0.7% of uranium-235. Uranium-235 is required to make nuclear reactors, also in making atom bombs, right? So these are examples of isotopes. Isotones have got the same number of neutrons. This N should remind you of neutrons, right? Same number of neutrons, but they got different atomic numbers, different mass numbers, right? The best example of this is S36, sulfur, chlorine 37, argon 38, potassium 39, and calcium 40. And if you look at the number of neutrons in each of them, it will be 20. Atomic number of sulfur is 16, so 20 neutrons are there in this sulfur 36, right? Chlorine, atomic number 17, mass number 37, so therefore you get 20 neutrons. Argon, if it is having a mass number of 38 and the atomic number is 18, again 20 neutrons. Potassium, atomic number is 19. This isotope of potassium is having 20 neutrons. And this is again having 20 neutrons. All these are isotones. You may think how these mass numbers have become these. These elements can have various isotopes, right? Each one of them. And these series happens to have the same number of neutrons, 20 neutrons. So they are isotones, right? Isobars have got the same mass number. They have got different numbers of protons and neutrons. The sum of the number of protons and neutrons is same. Again, we can have a series of these same elements. Sulfur isotope having mass number of 40. Then chlorine can have isotope having mass number 40. Argon also can have a mass number of 40. These may not be the most predominant isotopes of these elements, but they are there. Potassium 40 we can have, calcium 40 we can have. And all these have got the same number of protons plus neutrons, same mass number. Atomic number is different, 16, 17, 18, 19, 20. So number of protons is different, 16 protons here, 17 here, 18, 19, 20. Number of neutrons is different. To make it 40, this will have 20 neutrons, this will have 21 neutrons, this will have 22 neutrons, 23 neutrons, 24 neutrons. But the mass number is same. So these are examples of isobars. So in this lesson, we learnt about isotopes, isotones and isobars. Isotopes have got same Z. They are the same element, right? Isotones have got the same number of neutrons, this N neutrons, right? And isobars have got the same mass number. This is same. These two are interesting series of isotones and isobars. Very, very interesting.